Let's do another one. So number 3, 2 dice are rolled. What is the probability that the sum of the numbers rolled is either 4 or 7? Express your answer as a fraction in lowest terms or a decimal rounded to the nearest millionth. Okay, so really quick, let's talk about sums of die. So, when you roll a die, let me redo what I was doing. Okay, I'll call this die 1, I guess. There's 6 options, right? I can roll a 1, a 2, a 3, a 4, a 5, or a 6. And then die 2. All right, I'm not doing this very well. Let me just erase these die labels. Basically, for the first die, I can roll a 1 through a 6. For the second die, I'm going to write this as the column. You could also roll a 1 through a 6, right? Skipping numbers. Here we go. 1, 2, 3, 4, 5, 6. Okay. So when we roll 2 die, right? That's our options. We can roll 1 through 6 on one of the die. We can roll 1 through 6 on the other. So when we're looking at the sums of these die, so like if we roll 2 ones, a 1 and a 1, that adds up to a 2, right? If we can roll a 1 and a 2, 1, comma, 2. We could roll a 1 and then a 3. A 1 and a 4. A 1 and a 5. A 1 and a 6. Right? These are all the different things. And if we roll in a 1 and a 2, that's a sum of 3. If we roll a 1 and a 3, it's a sum of 4. Sum of 5, sum of 6, sum of 7. And we can keep going in this way. So if I go to the second row here, I could roll a 2 and then a 1. I could roll a 2 and a 2. A 2 and a 3. So on and so forth. So now I'm going to start going down this first column. So we could roll a 3 for the first die and a 1 for the second die. We could roll a 4 for the first die and a 1 for the second die, a 5 and a 1, or even a 6 and a 1. And I didn't fill all these others in, but it's the same idea. If I stick with this bottom row now, I could roll a 6 and a 2, or a 6 and a 3, right? All the way out to a 6, comma 6, which is a sum of 12. So, for this problem, they want to know the probability of rolling either so it's a sum of 4 or a sum of 7. So first thing I want you to notice is how many different options we actually have. And if you basically multiply these rows and columns, there's 6 columns, there's 6 rows, there's 36 different options. There's 36 different possibilities in the sample space. When we roll a pair of die, these are all the different possible pairings that could happen. There's 36 total different possibilities. So when we start writing down the probabilities, my bottom number is going to be 36. There's 36 options. So let's look at the probability of rolling a 4. Well, first, I want you to think about what are the different ways we can roll a sum of 4. So what about 1 and 3, right? 1 plus 3 is a sum of 4. But notice up here, I have a 1 and a 3, but we also have a 3 and a 1. So we actually want to count that as well. So you could roll a 1 on the first die and a 3 on the second die, or we could roll a 3 on the first die and a 1 on the second die. Right? There is a difference between these two pairs. because again, that first number represents one die, the second number represents the other. So we can roll a 1 and a 3 or a 3 and a 1. That adds up to 4. There's one more option, right? We could also roll a 2 and a 2 where they're both 2. Now that we only have to count one time. If the numbers match, if they're the same, you only count that once. We don't write that a second time. And you can see up here, like here's a 1 1. That's the only one in that row and column. Here's a 2 2. If I finished this, sorry, let me finish it correctly. If I finish this column with the 2s, it would be a 3 2, a 4 2, 5 2, and then we have 6 2. But again, 2 comma 2, it's only happening one time in that row and that column. So yeah, you only account for the ones with the matching number. When we roll the same number on both die, we only account for that one time. So there's 3 different ways out of all the 36 possible ways to roll those 2 die. There's 3 different ways to roll a sum of 4. So probability of rolling a 4 or a 7. We found the probability of rolling a 4. It's 3 out of all 36. Now we're going to find the probability of rolling a 7. I'm going to come back down here and let's write this out again. Let's think about this. All the numbers, 1 through 6, that will add up to 7. So, like 1 and 6, right? 1 plus 6 is 7. But don't forget, we also need to account for 6 plus 1. So 1, 6, 6, 1. What about 3 and 4? 3, 4, 4, 3. And then there's another one, 2, 5, and 5, 2, right? So these are all the different ways we can add up to 7 with these 2 die. How many are there? 1, 2, 3, 4, 5, 6. So there's 6 different ways to roll a 7. And then remember, we're supposed to subtract the probability of rolling a sum of 4 and a sum of 7 at the same time. But I want you to think about that. Is that actually possible? When you roll a pair of dice, you only get one sum, right? You add up the 2 die, and whatever your sum is, that's what it is. It's not possible for us to roll both a sum of 4 and a sum of 7 at the same time. It can't happen. So this last part, you can think of it as just being 0 out of 36. Again, that's because we can't roll a sum of 4 and a sum of 7 at the same time. So these are actually something we call mutually exclusive events. Mutually exclusive events are events that can't happen at the same time. Which basically means that there will never be an intersection between those 2 events. They can't happen at the same time, so the probability of those events happening at the same time is 0. It's just not possible. So really, when we have a mutually exclusive event, what happens is we just end up adding the probability of event A plus the probability of event B, and we don't have to worry about subtracting what's in common because there's nothing in common. But instead of, memorizing a new formula, we're still using this original formula up here, right? It's just there's nothing in common. The probability of those 2 events happening together is 0. So you can exactly think of it just like this. We're just subtracting 0 because there's nothing in common. So that can happen when you are working through your problems in Hawks. Sometimes there'll be some things in common and we need to subtract that probability. Sometimes there won't be. So for this one, if we add these top numbers, we get 9 out of 36. And you can reduce that or just pop that into a calculator. You actually get 0.25. So there will be a problem similar to this on your homework for Hawks. And basically, when they're telling you the two numbers to look at, whatever they are, the sum of this and the sum of this, I suggest listing out all the different, possible dice rolls that will give you that sum. And then your bottom number is always going to be 36 for these problems, for the sum of dice problems. There's always going to be 36 possible options. And basically, if you wanted, you could finish filling in this chart if you really wanted to, but this would give you all the possible combinations. All right, we got one more to do. And it's very similar to the one we just did. A single letter from the word Mississippi is chosen. What is the probability of choosing an S or an I? Okay, so what's the probability of choosing either of these letters? The probability of choosing an S or an I. So again, it'll be the probability of choosing the S plus the probability of choosing the I minus the probability of choosing both of those at the same time. So start with the probability of choosing an S. How many S's are there? 1, 2, 3, 4. And how many letters are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 4 S's out of all 11 letters. The probability of us choosing that S is 4 out of 11. Plus the probability of choosing an I, and 1, 2, 3, there's 4 I's. 4 again out of 11. There's 11 letters. So that's the probability of choosing an I. And then this is a problem similar to the last one. If we're picking a single letter from this word, is it at all possible that we can choose both an S and an I at the same time? Not possible, not at all. So you could stop here and just add these fractions, or if you just want to, finish the original formula, there's no way we can pick both of those letters together, so 0 out of 11. But either way, once we add all of this up, we get 8 out of 11. And you can type that in, or, find the decimal, which is 0.7272. It keeps repeating, but we want to go 5 decimal places, so we end at the 7. All right, so that is the addition rule of probability when we're trying to find the probability of either event A or event B happening. In the next video, we'll talk about conditional probability.